So here's the next question for the problem of the day, that is maximum number of points from grid queries. Okay, so what we have to do in this question, let's just understand from the example. You can read the question from the Leetcode. Okay, so let's just understand from this example, that is basically I have taken, and let's understand how the output is basically framing. Basically we have to return the resulting array answer. Okay, so the output will be formed in the array. Okay, so let's just understand. So here's the grid given. Okay, so this is the grid that will be given, and here's the query, one array. Okay, so this is the 2D array and this is the 1D array. Okay, so let's just understand what we have to do. This is the hard level problem. Okay, so in this, what you have to do, we have given a query. So every query that is here, this 5. Okay, so what we have to do, basically we have to check from top left. Okay, we have to start from top left of the grid, that is from here. Okay, and we can move in all 4 directions, that is here, here, and upper, and this. Okay, that is up, down, and left, right. Okay, from a cell. Okay, this is cell. And what we have to do, we have to check for every time if this number that is in the cell is smaller than this query, that is query I. Okay, the first query. Okay, so it is smaller than, we will add this query one, that is we will add 1 in the answer. Okay, so if I make a array of answer, then you will understand. Okay, so what at first query, that is at 5, we will add 1 because we can simply visit this first node, that is simply 1. Okay, so simply we will add 1. Okay, so this is valid because the number is shorter than the first query. Okay, then we will move its left and right, because up, basically not left, up and left is not valid because it is out of, we can't move out of the grid, we have to move in this direction. Okay, so we will move, then let's just move here and then here. So we will move here, so this number is also smaller, 2 is also smaller than 5, then this is also, basically this will also add again 1. Okay, so simply we will add 1. Okay, then we will also move here also 3, so this will simply add 1 more number, that is because it is shorter than. Okay, so then 3. So then from here, that is here, we are moving here 2, at this 2, then we can simply add 1 more, 3. Okay, then simply 4. Okay, then okay, from here also we can move here and here, you know that thing, and from here also we can move here and here. So we have moved here, here, and this and this. Okay, so if we move, then we will move here. Okay, this point, so this is also a valid, so we will simply add 1 also, then the answer would be here 5. So if you move, then move here from here, or so this will be simply equals to the query digit. Okay, so we, whenever the number is equal or greater than the query, then we have to stop. Okay, so the total number of possible cells that we can visit from this query is these 5. Okay, so that's why we have added 5 to its first place, that is this. Okay, so that's why here 5 is there. So total number of queries are there, so that's the same output will be formed. Okay, then with 6, how can we visit? Okay, one thing is that whenever we are basically using any query, okay, to visit, then we can't reach the same cell basically again and again. Okay, so that's the main thing. So in 5 we have visited unique number of 5 cells. Okay, we can't visit again and again to here, or again and again here. Okay, then for 6 we will start from again, that is this first index. Okay, then move this and this, so there will be 2, and then this 3, then this 4, then this is also a valid. Okay, from these 2, so we don't count 2 times, it is simply count as 1. So it's simply 3 to 5, then 6, then this 7. Okay, and then this also, because this has we can move from here to here, so simply it will, so the possible total are 8. Okay, so for 6 the possible digit numbers are basically we will get is 8 cells we can visit. Okay, so simply then for 1 last, basically for 2, so we will start from first cell. Okay, then we will move this and these are not valid. Okay, we can't come here. Then simply it is only 1 cell. Okay, so that's the basically how this output is formed. So these are the basically number of cells from one query that we can move. Okay, and we can move in left, right, and up and down direction from a cell. Okay, and we have to always start from first cell. Okay, so if you think of brute force, that is if you think of brute force, uh, that will simply brute BFS approach. Okay, we will start from 1 and then move in the direction that is possible, that is the here and here. Then we will simply check the number is smaller, then simply we will add the value, add the answer value in the answer. Then we will simply at last, when the query will be ended, then for next query we will start again from first. That will simply give TLE, because every time for every query we are starting from again and again, so it will simply give TLE. So to basically avoid this, to start from again and again, we can simply we can do one thing. That is, if you see that here, if we have visited 5, okay, if we have visited 5, that is the total number of possible cells are these 5. Okay, for this 5. So for 6, we can simply say these 5 will be included. We can simply add these 3 also. Okay, we can simply avoid to visit from starting. We can simply start from next cell. Okay, where we have stopped. So this is the approach, basically what we are going to use. So we are going to sort this query. Okay, and for every, like if we sort here, the 2 will come first, and for 2 the only valid cell will be first. Okay, so simply it will give 1. Okay, then for 5, it will simply not start from here, it will simply start from its adjacent cell, that is from here. Okay, these 4 will be added to it, so 1 is there, so 1 plus 4 is 5. Okay, then for 6, then so these will not be visited again and again, we will simply visit next. Okay, so simply it will give 8. So what we will do, we will first store all the queries with their indexes, so that after when we return the answer, the indexes are not lost. Okay, because we have to return in the form of this query. Okay, not in sorted way. Okay, in basically, so that's the main thing. So we will store these basically numbers, we will sort these numbers. Okay, query, but we will store it with their indexes. Okay, so first thing that we will do, then what we will do, we will take a minimum heap. Okay, so minimum heap will be used for visited pattern, like basically we will also use a visited array, so that will check we have visited. Okay, so minimum heap would also check for basically like it will store the value. Okay, and the indexes, basically the indices of the grid. Okay, that is if we start from 1. Okay, so let's just check how we are going to do the approach. Okay, so let's just sort this query. Okay, first we will sort this with their indexes. Okay, so I'm not writing the indexes, that will simply will see in the code. Okay, I'm just explaining you the approach. Okay, so first we will sort this. Okay, then we will start from here. Okay, that is 2. Then we will start from 2. So first we will start from first index. So at first we will simply store the first value, first this grid cell in the heap. Okay, so we will store with value and the position, that is simply 0, 0. Okay, so then when we will start, we will simply pop out this element and we will see that we have visited it. Okay, so simply whenever 2 will start from here, it will simply say that we have visited 1, so simply it will pop out the element. Okay, so one thing. Okay, so it will simply pop out the element, and basically it will first check the value is smaller than 2 or not. So simply it is smaller, then it will simply add the value in answer. Let's just make the answer also. Okay, so 3 cell, Okay, so in first cell we will simply write 1 because 2 was valid for 1, so it will add 1 to, because first cell is valid for 2. Okay, then it will store its adjacent, okay, in the heap. Okay, so it will store. Okay, so let's just store that is with value and the position, that is simply 0 comma 1 1 and 2, the value same, but the position is this time 1 comma 0. Okay, so these two will be stored when 2 will be formed. So if I just explain you again, the first was stored in this. Okay, so to compared the number with the value, that is simply 1, so it is valid, so simply it has stored 1 in the answer area, and then it has stored its adjacent basically number or cell in the heap. Okay, so then it will basically pop out the next basically first it will check the value with the 2, so it is equal, then simply it will not pop out the this value from the heap, and the iteration for 2 will be over, because it can't move any of the basically forward. Okay, then it will come, the 5 will come. Okay, it will start here, it will simply pop out, check for the next first element, that is it is smaller than 2. Okay, in heap, in minimum heap, you know that the basically values are stored in the smallest to greatest order, so simply it is the both value are equal, so simply it will be stored, it will simply pop out any of them. Okay, so it will simply pop out 2, so it will simply check the 2 is smaller than 5. Okay, then it will simply pop out and it will mark at visited. Okay, so simply the value here would be first mark at 1. Okay, because it will simply add 1. Okay, then it will visit next, it will pop out next, it will simply first compare the value, it is simply the value is small, then it will come here. Okay, then simply it will update the value with sorry no 2. Okay, no, basically because 1 was first stored, then simply it will update with 3. Okay, because it will always get the previous value. Okay, simply because for 2 1 was visited, so simply it will simply get from previous value. Okay, 1, and so these 2 are visited, so total value is 3. Okay, then when they are visited, so simply it will pop out these 2, so it will simply store the adjacent of them, that is this 3 will be stored, this 5 will be stored for this 2, and this for 2 the 5 is stored, then simply it will store 3. So the smallest of these 3 that are stored is these cells. Okay, because smallest number is 3, then 5, then simply these 2 will be visited, so these 2 will be simply visited, so the total number of value would be simply 5, because if you calculate the number of cells are 5. Then this is also will be stored. Okay, when this will be pop out. Okay, this will also stored because this is the adjacent. Okay, this will not stored because this has visited. Okay, this will simply be stored, and for this will also stored. So when for 5, this will be, these 3 are the basically now stored in the heap. Okay, so it will check for 5, it is not valid because 5 is equals to the 5, then simply for 5 the value will be end. Okay, then it will come for 6, it will first store the value that is same as 5. Okay, then it will check for these 2, that is now the minimum heap contains these 3. Okay, so simply it will go for first, that is smallest, so simply it will check for this 5 and this 5, so simply it will add, so the total number value of 7. When this 5 will be checked, then this will be simply included in the heap, minimum heap. Okay, so these will be simply pop out because these are checked, then simply when this is checked because this is smaller than this. Okay, so this will not check first, this will simply check first. Okay, so simply it will, the value will be simply come 8 because 7 has come. Okay, simply 8 will become. Okay, then we will simply, this will also be pop out. Okay, this is also visited, then simply we will check for 7, the value is basically greater than the query, then simply it will end the loop. Okay, so simply this will the array that will be formed and then we have stored the indexes, so simply we will return it with basically put out these values according to the indexes. Okay, so basically this is the total approach that we are going to use. Okay, so I will show you the code in Leetcode. Okay, so that's the okay, so here's the code I've written. Okay, so I've written the comments also, so you can, because it's a hard problem, so that's why I've written the comments, so you can understand the things. Okay, so first we have simply initialized the values. Okay, row count, okay, and column count, and this is the result array. Simply it will give the result. First we have stored the 0 at indexes. Okay, we have this directions. Okay, that will simply store the direction, that is right, down, and left and up. Okay, so this is the values. Okay, this will help in moving the this cell. Okay, then we will store these queries. Okay, I have told you we will store these queries with their indexes. Okay, you can see, and then after we will then sort it. Okay, simply we have sorted at ascending order. Then we have initialized the minimum heap. Okay, and then we have also initialized the visited. Okay, that will simply create a take care of the visited. Okay, that how many we have visited, so that we can simply we can't go again and again on a cell that we have visited. Okay, so simply then we have we are tracking care of the number of cells that we have processed. Okay, then simply we will push the first grid simply with the value. Okay, that this is the value and this is the cell, the position of the cell. Okay, then simply we have updated the visited value true for first cell because we have pushed the value. Then simply for every query in the sorted query, we will simply loop out the till the minimum is not empty. Okay, because we have not visited all the nodes. Okay, it will simply push the nodes, not nodes, basically cells in the minimum heap until the minimum is not empty. So and the minimum heap dot top, basically the value is not smaller than the query value. Okay, so this loop will move till. Okay, then for every value simply we will pop out the value, and then simply we will store this value in the current row and current column simply, and then we will make a total point plus plus. Okay, then we will move this with direction. Okay, we will explore all four possible direction. Okay, then simply you can see we have just added the values to move. Okay, then simply push the all the directions value. Okay, we have seen. Okay, and we will make visited true for all the. Okay, that will simply pushed. Okay, adjacent values, that is if it has left, right. Okay, I've told you in the code. Okay, we will simply store the first we will check for cell, and then we will, after checking, then we will store the adjacent in the minimum heap. Okay, then this loop will exit, and then simply it will store the result in the total points. Okay, the total points will be stored in the result at every index. Okay, then simply we will return a result. Okay, you can submit it. And you can see time complexity also, that is simply going to be of n log n plus q log q. Okay, you can simply see the space complexity also. Okay, so that's the code.